Hello everyone, thanks for coming to the summary of week 11 for the Discrete Mathematics course. So in this week, we talk about division and the greatest common divisor. Suppose we have two integers a and b. There exist integers q and r such that a equals to q times b plus r, where r is a non-negative integer greater than 0 but smaller than b. Moreover, there is only one such pair of integers q and r that satisfies these conditions. So q is the quotient, r is the remainder. From this, we can define the greatest common divisor of a and b, the pair of integers, provided that if d is a common divisor of a and b, that is to say d divides a and d divides b, and if e is a common divisor of a and b, then d is greater or equal to e, then we call d to be the greatest common divisor of a and b. A corollary is if e is a common divisor of a and b, then e divides d. The greatest common divisor is written as GCD a and b equals to d. So how do we find the greatest common divisor? So the straightforward method is to write out all factors of a and b. The second method is to do the prime factorization and compare the prime factorizations of a and b. The third method is the Euclidean algorithm. So that is to say, if a equals to q, b plus c, then GCD a and b equals to GCD c and b. Then we can do the long division. So there are some properties of the greatest common divisor. There exist integers x and y such that GCD a and b equals to ax plus by. And next is what we just introduced. For adding e divides a and e divides b, e divides GCD a and b. Specifically, if GCD a and b equals to 1, then we call a and b to be relatively prime. That's a summary of what we have learned this week. Thank you.